Kia ora koutou. Here are 3 more questions from the qualifying round of the Caltech Integration Bee 2024. The questions are slowly cranking up in difficulty, but these ones are still very doable. So if you're a New Zealand student watching this and you're starting to think about the Scholarship Calc exam, I just wanted to say a couple of things about what you would be expected to do in that exam if you had problems like this. Because integration by parts is not covered in the New Zealand curriculum until tertiary level, if you had to use IBP or it was a good option, they would give you the formula for integration by parts. However, if you haven't used that formula before, I think it's quite hard to do, and integration parts is a wonderful technique that's well worth learning. So one of these problems here I did use IBP for, just if you need to learn it, go and watch my other videos on that, or watch any other videos on integration by parts. The other technique that you're definitely going to want to use here is substitution, but some of them, there are some things that you can do before you get going to the integrand that will suddenly make things look much easier. All right, so I'm going to get started. I'm going to start on question 8, which is this nested fraction thingy. So I guess as soon as I saw it, I thought, well, we really don't have a feel when we start out for what this might simplify down to. So I'm going to call that thing in the middle, I don't know, big A, and then I'm going to work with cleaning that up and then just see where we get to. So big A is equal to 1 over 1 plus 1 over 1 plus 1 over x. So let's just go in steps. It's kind of like playing pass the parcel. We've got 1 plus 1 over x is equal to x plus 1 over x. So 1 over 1 plus 1 over x will be x over x plus 1. So that sorts out that. And that gives me 1 plus 1 over 1 plus 1 over x is going to equal x plus 1 plus x, just getting a common denominator, right? So what we're doing here is really just like year 9 fractions. And now we want 1 over all of that. So big A, which is 1 over all of that, will be x plus 1 over 2x plus 1, which is obviously a much, much simpler integral to work with, but still kind of cool. Let's see what we've got. We've got from 1 to 0, and then we've got x plus 1 over 2x plus 1 dx. Now, you could go ahead and do some substitution stuff on it, but I didn't do that. I had a bit of a look first at forcing the numerator to fit into to being a multiple of the denominator. So that's often a good place to start. So we're going to have the integral from 1 to 0, and then we've got a half of 2x plus 1. So what I'm trying to do here is I'm trying to match up the x plus 1, but I'm forcing in a multiple of 2x plus 1. So the reason I've got a half is because I'm trying to match the x, and I've got a 2x. So if we expand that out, we get x plus a half, but we want plus 1, so we need to add in another half. But you can see now that this has collapsed down to like a merit level 3 problem, because we've got 1/2 plus 1 over 1/2 of 1 over 2x plus 1 dx. So integrating that gives me 1/2 x evaluated between 1 and 0. And then this next bit is going to be, I'm going to do this really slowly. So we'll pull out the constant. Look, obviously in the Integration Bee qualifying round, it was a speed challenge, so you wouldn't want to be doing it this slowly there. But if you're learning how to do it, then this is better. So we've got a half coming from here. Now when we look at this integral, we've got a straightforward natural log integration problem. So we'll just leave a bit of room for our constants. I'll leave the half out here. So we're going to have the natural log of 2x plus 1. When I differentiate that by the chain rule, I get a 2 coming out. I don't want the 2, so it's going to be times by another half. And we can clean that up into getting 1/2 plus 1/4 times the natural log of 2 plus 1, which is 3, minus the natural log of 1, which is 0. So we get a final answer of 1/2 plus 1/4 ln of 3. Now I'm up to 5 minutes already, and that was definitely I think the easiest of these questions. So we might only get through 2 in this video, sorry. Right, so that's my final answer for that one. Now, problem 9, I want you to take a look at first and have a go. I think it's a really, really lovely question. So I don't know the people who wrote these, but this was a cool problem that I might steal for my class this year somewhere. Maybe it'll appear in a test or something exciting. So you can see we've got limits of e squared and e. We've got the natural log of ln of x plus 1 over ln of x. So this is looking to me like I'm going to use substitution early on, and then maybe I'm going to use integration by parts, or maybe not. And I'm also noticing that I've got 2 icky looking integrals here. So I think I'm going to split this up into 2 and just see where we go. But the first thing I will do is I'm going to do the substitution. It doesn't really matter, as usual. You can start in lots of different places, so just start. Okay, so the integral goes from e squared to e, and it's the natural log of x plus 1 over ln of x dx. All right, cleanup time. I'm going to call this I1 plus I2. I'm going to use the same substitution for both integrals though, so some stuff will kind of be in both. So let u equal the natural log of x. That gives me du by dx is equal to 1 over x. So du is equal, so x du is equal to dx, separating the variables. Now, we really don't like this. Our job is to replace dx, but in terms of u. So working back to here, we get e to the u is equal to x. And that means that when I split this up, I'm going to replace that dx by e to the u du dx. Okay, so let's look at what we're ready to replace. We've got this ready to go, this is ready to go, and this is ready to go, but now we have to change over our limits of integration. So my x limits were e squared and e. U is equal to the natural log of x. So here we get 2 and here we get 1. Right, so let's split this into 2 integrals and see what we've got. So big I is equal to this integral, so the natural log of u times e to the u du. And then the next one is plus the natural log, plus 1 over the natural log of x, whoops, so that's 1 over u. That noise in the background is my very annoyed dog because I popped her into the crate to make this video. So there's always something going on here. Right, there we go. We've got these 2 integrals, and I'm not loving either of them, but they both look like integration by parts might be a cool way to go. So I'm going to start with evaluating this one and see where we get to, and then I'll do this one. Right, now I'm choosing one part that I want to leave and differentiate and one part that I want to integrate. I'm going to make this the part that I integrate and this the one that I leave. So that gives me the integral of the whole thing is going to be the natural log of u. When I integrate e to the u, I get e to the u, evaluated at 2 and 1, minus, differentiate this, and I get 1 over u, times the integral of e to the u from 2 and 1 du. Now, if I just look at that on its own, that's cool. We can see that we can work out this easily. So that's the first bit. And then I've got the second bit. Now, if you were lucky enough to do it kind of that logically, where you happen to like do this integral and then you look at this one, then you're straight away going to see the super cool thing about this question, which is that these two are the same and we have one minus the other, so that term is 0. So we're done, right? So the integral is equal to the log of 2 times e squared minus the log of 1 times e, which is 0. So my final answer is e squared ln of 2. I think I'm interested to hear if you're in 13 NCEA or SchoolCalc, if you did see that straight away, or if you started to go down a bit of a rabbit hole with trying to work this out. And then eventually you go, well, I'm not getting far on this, so let's go back and see what I've missed. And then probably you'd put this back in there and see what you've done. Okay, last question, which is also really nice. Yeah, so again, we're looking at it and you can see x cubed, x to the negative 3, yuck, yuck, yuck. Let's do some algebra work off to the side first and just see what's going on here. So there are a few different ways to do this. This links to one of the things that we do in the first scholarship calculus session, which is looking at the sum of, looking at expanding cubics. So x cubed plus x to the negative 3 over x plus x to the negative 1. Well, we can write it out first of all without the negative powers just to see what's happening. We've got x plus 1 over x. But if you're kind of just looking for basically dividing it out and getting a simpler expression, let's just see what happens if we take the denominator and cube it. So if we have x plus 1 over x cubed, that's going to give me x cubed plus 3x squared times 1 over x plus 3x times 1 over x squared plus 1 over x cubed, right? So that's just doing an expansion using Pascal's triangle, like a basic binomial expansion there. So that's my coefficients are coming from my third row of Pascal's triangle there. If you're watching and you're not confident with that, there's some AS videos, Cambridge AS videos on simple binomial expansions. If you go to my AS playlist, you should be able to find them. Or just leave me a note and I'll pop a link in the comments. So x cubed plus 3x plus 3 over x plus 1 over x cubed. So you can see that what we've got here is we've got what we want in the top line plus this term here. So we've got x cubed plus 1 over x cubed plus 3 into x plus 1 over x. So if we go back to the integral that we're after, let's see, what are my limits? Oh, it's gone very small. Just a sec. Right, so my limits are 2 and 1, and this is the integral here that we're working with. Okay, I don't know how I managed to do that, but there we go. So we want to integrate between 2 and 1, x cubed plus 1 over x cubed over x plus 1 over x dx. We can rewrite this as x plus 1 over x cubed minus 3 into x plus 1 over x divided by x plus 1 over x. I'm going to run out of time, so I'm going to jump a couple of steps. Okay, so we've got the integral of x plus 1 over x squared minus 3 dx. When we expand that, we get x squared plus 1 over x squared plus 2 minus 3, so that's a minus 1 dx. Oh, I might get it finished in time. That gives us 1/3 of x cubed minus 1 over x minus x, evaluated at 2 and 1. And when we clean all that up, we get 8/3 minus a half minus 1 minus 1/3 minus 1 minus 1, giving us a final answer for this one of, what did I get? 13/3 minus 5 over 2, which gives 11/6. Right, amazing. I actually got all 3 questions done before I run out of time on the video. Hope you liked those. There are definitely different ways to do that algebra in the last question, different places to start, as there often are with integration problems. So I'm going to try and do question 11 and 12 later on today. Then maybe finish this one off tomorrow. Not that you really care. All right, have a great day. Bye.